Aloha! In today's Astrobreak, I'll be talking about why stars twinkle. You may be surprised to know that if you were to travel out into space and look at the same stars that you have been seeing from the surface of the Earth all your life, those stars would not be twinkling. In fact, stars themselves don't twinkle. It's the Earth's atmosphere that makes them appear like they are. To understand why, we need to understand something about light. When light changes the medium that it is traveling through, its speed also changes. For example, in the vacuum of space, the speed of light is 299,792.458 kilometers per second. But light traveling through the air on the Earth only travels at a measly 299,704.645 kilometers per second. That's 0.03% slower. This change in speed is accompanied by a change in angle. We say that the light is refracted. This is why a straw looks bent when you put it inside a glass of water. Light from the top of the straw only has to travel through the air before it enters our eyes, whereas light from the underwater part gets refracted when it changes medium through the water into the air. The bent light makes it appear as though the straw is bent. Now, unlike a glass of water, the atmosphere does not sit still, and it's comprised of many different layers that have different temperatures and thicknesses, and all of this affects how the light is bent at a variety of angles as it makes its way down from the sky to the Earth. Wind and other effects are making the atmosphere slosh around constantly, so these angles are rapidly changing in fractions of a second. This is what makes steady light rays from stars appear as if they are twinkling. Fun fact, astronomers do not like it when stars twinkle. We have very sensitive observations to be performing, so we'd prefer if they just sit still. It's like when you take your kid to get some nice photos and you just wish that they would sit still for the picture, but they're just squirming and wiggling. Same kind of thing. To this end, we have developed moving mirrors. These bend and twist and change their shape in fractions of a second to do the opposite dance of the atmosphere so we can cancel out the twinkling effect. This is called adaptive optics. And the Gemini Observatory has produced this wonderful video to show us how this system works. It starts with a very high-powered laser that you strap to the side of your telescope. And then when you're observing, you shoot this laser in the direction that your telescope is pointing. The laser travels high up into the atmosphere, above 50, 60, 70, 80, 90 kilometers, so it experiences the same refraction and bending as starlight will. Since we know what the laser should look like, from the Earth we can measure any deviations from our expectations. Light from the laser enters the telescope by bouncing off of two mirrors and then traveling towards the instrumentation, which lives at the back. Inside the adaptive optics system, the light first passes through a filter, and then it gets split up into two directions. The first beam goes towards a computer that images and analyzes what the laser looks like. Doesn't look so good, does it? That's because the light from the laser is being refracted and bent by the ever-changing atmosphere. But by using the computer and our knowledge of what the laser should look like, we can calculate corrections. And we feed those to this deformable mirror that bends and changes shape to apply those corrections to the incoming light. In this way, all of the stars in our field will appear to our imaging system as if they are just sitting still and the atmosphere wasn't even there at all. Mahalo nui! Thank you so much for tuning in. Until next time, I'm Spaceman Steve.